right, this is 10.1. It's about stem and leaf plots. Could I have a volunteer read the learning target where it says LT, please? Yeah?
Explain the data in the stem and leaf plots.
Thank you. So a stem and leaf plot basically uses the digits of the different data values to organize a data set. Each data value is broken into a stem, which is a digit or digits on the left of the number, like kind of the first digit or a couple of digits, and then a leaf, which is the digit or digits that are on the right. So imagine, what I imagine a stem and leaf plot is taking your number and taking a pair of scissors and cutting it apart so that you're splitting it and you're putting, for example, for a 2-digit number, you're putting the tens digit on the left in the stem column, and you're putting the ones digit, the digit that's on the right, in the leaf column. So here's your example. The key right here is what explains how to read the plot. So this key says 2 line 0 equals 20. What that means is a stem of 2 followed by a leaf of 0 represents the number 20 together. So what that's telling me is that every number on this plot, they took scissors and they cut it apart into the left digit and the right digit. I'm seeing some confused faces. It's okay. We're going to practice it. It will make sense. So here where it says stem of 2, that means every single number over here is the ones digit in a number that starts with a 2. So 20, 20, 21, 22, 25, 27. So we're basically saying, oh, all these numbers start with a 2. So I'm going to put the 2 over here and just put the number that follows it all over on this side. This one is anything in the 30s. So 31, 34, 38. This one is anything in the 40s, 42, and then the 50s, 58 and 59. So really what you're doing with the stem and leaf plot, again, is taking a pair of scissors and you're cutting apart your number so that you have a digit or some digits on the left and then a digit or some digits on the right. So we're going to make a stem and leaf plot. Before we even do anything, we're going to set up the stem and leaf plot because every single one is set up in the same way. We literally write the words stem and leaf. So I'm going to write stem, draw a little vertical line, and I'm going to write leaf. So every stem and leaf plot is always going to begin that way. Reese, you got a pencil because you need to be taking notes right now? Now, the next thing I need to do is I need to look at my numbers and determine where I want to cut them, essentially. Because if I have like a 3-digit number or something, I might have to cut it differently than if I have a number that only has 2 digits. Okay. My numbers here, I have a couple single-digit numbers, and I have a lot of 2-digit numbers. So what I'm going to choose to do is cut them between the 2 digits, meaning on the left is going to be the tens place, the number in the tens place, and on the right will be the number in the ones place. So if I had the number 54, I'd put a 4 as the stem, a 5 as the stem, and a 4 as the leaf, just cutting it right in half. But then what do you think I do for my single digit numbers? They only have 1 digit. Dash? Exactly, because they have a 0, an invisible 0 in the tens spot, so I can make that my very first stem. And I know that the leaves that go on this stem are basically going to be all my single digit numbers. How high up into the stems do you think I need to go? Like, what's the highest stem number that I will need based on my data? Grayson? A 5. So I start at 0, and then I'm going to go 1, 2, 3, 4, 5. Now, I know there's nothing that's in the 40s, but we shouldn't be skipping the 4. We should still put it there because that can show us a gap in our data that we have nothing in the 40s. All right, I have my stem. Now I'm going to put my leaves. The leaves are always going to go in least to greatest order. So I start with my stem of 0. That's all my single-digit numbers. My single-digit numbers are 2, 3, 5, and 6. So I'm literally going to put 2, 3, 5, and 6. Each one of these numbers has an invisible 0 in front of it, which is why they are all going next to the stem of 0. They all have that same stem. Next, my stem is a 1. So this is any number that is in like the teens, starting with 10 up into the teens, all the way up to 19. And again, I want to put these in least to greatest order. So I see that I have a 10. What leaf should I put for the number 10? Mia? Because it has a 1 and then a 0. My next is a 14. So what leaf should I put for that if it's a 14, Nathan? Because it's a 1 followed by a 4. And then my last number that starts with a 1 is 18. So what leaf should I put for that? Neil? Because each one of these numbers begins with a 1 in the tens place. 10, 14, 18. Next, I'm doing any numbers that start with a 2. So anything in the 20s from 20 to 29. The only thing I have in the 20s is 23, but I have 2 of them, which means I need to put 2 3s down to represent those 2 23s. 23, 23. Next, I have the 30s, anything that's in the 30s. I have a 30 and a 36. So what are the 2 leaves that I need to put on the stem of 3 if I have a 30 and a 36? Natalie? A 0 for the 30 and a 6 for the 36. Because remember, each one of these is going to be read out with the 3 in front. 30, 36. I have nothing in the 40s, but I'm not going to put a 0 there because some people are like, oh, put a 0 then if you have nothing. Why should I not put a 0? Why would that be wrong? Tanisha? Yeah, and we want to say that there's nothing, so I'm just going to put nothing. If there's no leaves, that implies there are no numbers that have that stem, so nothing goes there. And then last, I have 55, so I'm just going to put a 5 right there. Ta-da! You can see how a plot like this can kind of show you the way your data is distributed. See how there's like a lot more up here and it starts to get less and less as we go down? That's the point of a plot like this. It can help show you how your data is distributed, where there's a lot and where there's a little. There's one more piece we need to include with this stem and leaf plot to make it fully complete. That's the key. You always have to write a key for your stem and leaf plot. The key is just basically one number represented in a stem and a leaf so I can understand how to read it. So what I mean by that is if I choose the number 23 in my plot, that would look like a 2 on the left and a 3 on the right. So what I want to say is if I have a 2 on the left and a 3 on the right, that means 23. That way somebody looking at this understands how to read it. I've had people in the past go, well, isn't that how you would read it no matter what? No. Can anybody think of something different that the 2 and the 3 could represent instead of 23? Dash? I'm trying to think if that would work, if it could be like a fraction. Maybe, possibly. Any other ideas about that, Grayson? Decimal. It could mean something like this. That's why we have to put the key so that somebody understands what it's representing. It could actually even represent 0.23. It could actually represent 2300. It could represent really any number that has those digits of a 2 and a 3. So that's why we want to specifically show that it means 23 in our plot so somebody else would understand how to read it. They wouldn't make the mistake of thinking it was 2.3. Questions about example 1? Okay, so we've learned how to make one. Now we're going to answer some questions about one. The stem and leaf plot shows student quiz scores. Part A, how many students scored less than 8 points? So this is an example of our stem and leaf plot representing decimal numbers. So we can see a 9 and a 2 means 9.2 rather than 92. So how many numbers here are less than 8? Less than 8. Ratisha? What'd you say? 5 numbers because we have 6.6 and then we have several things in the 7s. So one number that was up in this category and then 4 here for a total of 5 scores that are under 8. Part B says, how many students scored at least 9 points, meaning 9 or more? How many students scored at least 9 points? Kaden? 4, because we had 3 people that scored somewhere in the 9s and 1 person in the 10s for a total of 4 students. And then part C says, how are the data distributed? So we're going to learn later in 10.3 the different names for the way that data is distributed. But if you look at this, do you see how it kind of goes up and down almost evenly on both sides? Like this one didn't, it had like a lot and a little, but this one goes almost evenly up and down. We would call that symmetrical data, meaning it looks almost the same on both sides. Now I know it's not perfect, right? There's like 3 numbers here and 4 there. It's not 100% perfect, but it's pretty darn close to being equal on both sides, meaning we would call it symmetrical. Questions about that one?